I started thinking, and I have a real affinity still for all the work that we were doing in those days. And it got me thinking, can I build something useful with ML? Can I do that myself? After all, I've been telling all of you for years now how easy it is to integrate ML into your applications. Yeah? However, I needed to make sure and really wanted to do this myself. So what do? Actually, I tried to catch up on 40 years of radiology work, innovations, talk to doctors, go to hospitals, understand what the current problem space is, and try and find one particular problem, a small problem, that maybe I could try to see how much work it would be to build a solution for that. Yeah, and I took some courses in ML University, spoke to AWS ML experts and things like that, just to get me up to speed, not just about the principles, but about the practicality of it. Yeah. And one of these, in this hospital in Dublin, where I talked to one of the stroke specialists, he hammered on me saying that every second when a person has a stroke counts. A stroke patient loses 1.9 million neurons a minute if they're not being treated. So quick treatment is crucial. Okay, that sounds like a reasonable, simple enough problem that I can attack looking at brain hemorrhage in X-rays. Yeah? And if it would be like this, in case you can't read it, the big white spots there are basically blood hemorrhages in the brain. If they would be this big, that would be easy. But often they're not. They're micro lesions, or really sort of continuous micro strokes and things like that you can still detect using CAT and MRI scans, but it's much harder. And so I was starting off thinking like, can I build an ML pipeline that sort of can sort of decide whether on an image there is actually a brain hemorrhage. And then if you would actually find a positive, you would actually sort of prioritize that in a radiologist's work list so that it could be immediately evaluated. So as all with that, if you don't have good data, you don't have good AI. So that is immediately step number one of my stumbling block. How would I get access to data and imagery that I actually could train my model on? Well, actually, turned out that was not that hard. Kaggle has a data set with 700,000 pre-labeled CT brain scans. Yeah? That allowed me to actually immediately get off to a start. So download that set, put it in S3, and as always, when you do this, you sort of split the data set up into the set where you're going to train it with, how you're going to validate it, and how you later on are going to test whether the model actually works. Yeah? 17, 15, 15 is a common practice there. Next thing to do, fire up SageMaker, push this button, and now I have to write some code. And so pretty common in that is you're actually using Python. And if you just realized, I'm not necessarily that proficient in Python. But the Python SDK actually has a whole bunch of built-in algorithms and pre-trained models from popular open source model hubs that you can immediately use. So I selected an architecture that I've researched, and I can fine-tune it with my data set. So the only thing to do now is actually to add the code, to launch the training job, push a button, and it gets immediately scanned through, and this model gets created. Wow, that's easy. However, under that button push that I did, there is a lot of work happening. Yeah? And I don't know if you know much about sort of deep learning and how these models are being built with multiple layers and things like that. Basically, you push an image through, goes forward, goes that, and a loss score is being calculated. The loss score needs to be as low as possible. Yeah, the lower the loss score, the higher the accuracy of the model that you've built. Okay, if the number is high, you basically go back, you backtrack, and you adjust the weights and the biases in the model, and then you go forward again and to see what the outcome is, and you go backward again. And you do that for 700,000 images. Oh no, 70% of the 700,000 images. Yeah? And at the end of this pass always, you end up, you have forward pass, backward pass, forward pass again. Yeah? And all of this happens under the covers when I push that one particular button. Pretty amazing. And so then you get actually out of that, you get a model. And again, with one click of a button, I actually get an API endpoint for this model, where I can start putting my imagery through and get a prediction score, what the likelihood is that this CT scan brain image actually has a hemorrhage in it. And actually it turns out it works pretty well. I was quite proud of myself when I built this. And of course then, being the person that likes evolvable architectures, I start plugging all these different AWS components around it, reorganize the radiologist work list. And then something came to mind that when I visited that hospital in Dublin, where the neurologist actually said that he rather gets waken up at night at 3 a.m. for a false positive than not being waken up at all. Because every minute counts. So he doesn't want to wait until the radiologist gets to his reprioritized work list. He wants to get an SMS at night at the moment that my model detects that there is a brain hemorrhage. Yep. Evolvable architecture. Yep. And that SMS can actually send an SMS to the neurologist, and he can immediately on his phone take a look at the image, whether or not he should immediately jump in his car and drive to the hospital. It is that simple. It is not that hard to build these models. Anybody has been talking to you about AI and ML and building these models, how hard it is not that hard. Yeah? And actually, by the way, this is in no way a production system. This is my hacking on a Friday afternoon, 5 weeks in a row. And of course you can start augmenting it, because as always, when you do one thing, you want to do all the other things. You could do, for example, use class activation maps, which sort of indicates what is it actually in this image that the model was actually looking at. And again, building a machine learning model is really sort of an interactive cycle. Now, as I said, this is in no way a production system. But, however, I'm very, very happy that a number of people on the AWS team actually did pick it up. And I'd like to thank Priya, Wally, and Ekta for actually taking my horrible code and turn it into something that might be a learning experience for you guys as well. So all of this is available for you on GitHub to experiment with and to see how easy it is to actually start building these ML models. This is really what I want you to walk away with. If I can do it, you can do it. Yeah.
Thank you for watching, and stay tuned for more exciting content on AWS services. Like, share, and subscribe for the latest updates. See you in the cloud.